All right, I thought we'd start with a warm-up. So if you're watching the video, you might try to find x in that triangle first, and try to do it without your calculator as well. That's definitely the way you want to progress. Okay, guys, so can you help me out? Which ratio should we use to find x in this triangle?
Cosine.
Cosine? How'd you guys pick cosine?
Because you have the adjacent and the...
Cool. If we're looking here, we've got the one that's next to it, that's the adjacent, and we've got the hypotenuse. So we're going to go cosine of what? 60. Alrighty. So cosine of 60 equals 12 over x. Alright, so now we're supposed to be solving for like x, of course, trying to find out how long that side is. So how are we going to do that? This one's a little different than anything we saw yesterday. Multiply by x, because you got to get rid of this fraction, right? It's like a rational equation. Then we usually try to get rid of that by using like the common denominator. I mean, this one's super simple. It's just the only denominator. But yeah, it's the same idea, okay? So let's see what we have left. We've got then x cosine of 60 equals 12. If we want x by itself, I've got to move the cosine of 60. So I'm going to move that number, whatever it is, over here. So then I'm going to have x is 12 divided by the cosine of 60. And if you want to be good at trigonometry, you do not do that with your calculator. I told you a little story about students taking classes other places and not being prepared at all for those classes yesterday. Well, that's right here. So cosine of 60, how do I do that again? I like draw the 30, 60, 90, and I try to do it from memory. If you try to do it a few times, you're going to be able to do it in no time. So 30, 60, 90, something like this. I'm going to draw the 60 right here. There's the 30. There's the 90. I remember opposite 30 always goes 1. Opposite 60 always goes root 3. And the hypotenuse is always 2 for that triangle. And then I say, okay, now I can figure out the cosine of 60 or anything else like that. So if I look here, the cosine of 60, how do we do cosine again? It's adjacent hypotenuse, right? So it's 12 divided by 1/2. I think 12 divided by 1/2, even without doing that with algebra, I would do that by just thinking commonsensically. 12, how many times does 1/2 fit into it? 24 times, that's the answer.
I got that same answer, except I didn't do that. I just did it right.
Yeah, you did it right there? Yeah, that's great. Yeah, that's fine. So Akash decided to do cosine of 60 right here and get 1/2, and then he divided by 1/2 or multiply by 2. Yeah, sweet. So that's just as good. Totally. Remember, if you're doing this rule of fractions here, here's the main fraction bar. The main fraction bar, if you divide by a fraction, you keep change flip. Good. Which is going to be 24. Right? If you couldn't do it with common sense, because sometimes it's harder to do that. And let's make sure this makes sense. Does 24 possibly make sense for how long that could be? Yeah, that's reasonable, right? If you made a mistake, most likely you're going to get a ridiculous answer rather than a reasonable answer, and you'll know. Does that make sense? Okay. So I'm not sure we did this yesterday, but I think you guys probably don't need much more advice. If I want to find the 6 trig ratios for this angle, this is another common letter for angles. It's the Greek letter phi or phi. People pronounce it differently. How do I do that? Find the hypotenuse. Oh, I guess I should tell you this is a right triangle. If I don't, this is an impossible problem. So, yeah. Kind of need that. So we're going to use Pythagoras to figure this out first. So a squared plus b squared equals c squared. Which things do we have?
A and B.
We have A and B. As long as you put them in, it doesn't really matter which one goes where. You could put the 48 for A, the 14 for B. You just can't put either one of those for C, because the hypotenuse is the thing across from the right angle. Yeah. Then you can use your calculator to help you. I'm sure we don't know these squares. 14 squared, what is that? You guys help me with your calculator?
Yeah, it's 196.
196 is correct, yeah. I don't know 48 squared. You're going to have to help me. What is that?
2,304.
2304?
Yeah.
Okay, so if you add those together, ooh, that comes out pretty nice, doesn't it?
25.
The 2500. And I think that is a perfect square. If you square root both sides, you get 50. which makes sense with our picture that we drew. I think we're good. So we can just label that on the picture. And now we can come up with our 6 trig ratios. Can you guys remind me? Let's do them over here so we have lots of space. What are the 6 trig ratios in all of trigonometry again?
Sine, cosine, tangent, cosecant, secant.
Good. I need to put phi, right? Because we're talking about that phi. So we'll do the main 3 first. Sine is going to be what? Looking at this phi. Opposite hypotenuse. 14/50ths. If you can, simplify. If you divide by a square root, which you will on some problems, you should rationalize. I showed you how to do that yesterday, right? If you like have 3 divided by square root of 2, use that square root of 2 over 2, clever one, and rationalize it. If you get in that habit, you'll have less trouble later on, believe me. If you don't, there'll be a couple things that are a little trickier. So, it's up to you. This goes to what, 7/25ths? Cool. Cosine, if we're looking here, we got...
Adjacent.
Yes. So it'll be what?
50.
And then tangent, we're going to go opposite adjacent. Do you guys see how when I am doing these problems with you, do you think I'm really even thinking in my head opposite over adjacent?
No.
Does it look like I'm doing that? If you were careful about watching me there, I was like putting that on as like the after effect. I was already looking at the triangle and going, does that make sense? So I don't think about trig ratios anymore according to this opposite adjacent stuff. I know that sine is like the thing that's far away from where I am, wherever my angle is. So I think of sine as this vertical notion in general. And cosine is adjacent, right? If I'm here, if the angle's right here, I think of cosine as this horizontal notion. It's the thing next to me, where my hand is right now. Does that make sense? And when I do tangent, it's like the ratio of those 2 things. So that is where we ultimately want to go. If you go there, then some stuff in more advanced trigonometry will be easier. I mean, you can still do it the old-fashioned way. This is where we're starting. But see, I think about these spatially, not in terms of words. So, just a preview, okay? Okay, so you guys told me the other ones. What's the partner of sine? Cosecant of phi. And partner of cosine? Secant. Write them horizontally next to each other so you start to remember which one goes with which. And cotangent is the easy one, I think. So I'm flipping. And we are done. There you go. There's how you do the 6 trig ratios. If you haven't, go ahead and do number 4 on your handout. If you're watching the video, definitely pause it and do number 4 on the handout that goes along with it. I wanted to talk one more time about the thing that you're going to mess up if you're not careful, which was
The depression angle.
the angle of depression. Very nice, you remembered. So hopefully that will help you if you remember. This is the one thing that people generally mess up in this section, I think. Besides that one we started with today, if you divide by x, remember there's like an extra step in the algebra, it's a hard step. Be careful with that, okay? So I drew the Nautilus from 20,000 Leagues Under the Sea, which was Captain Nemo's ship. Who wrote that? Jules Verne, very nice.
Do I get money?
That was a hard guess. You just guess a random submarine next time. You got to take out Connor. Okay, so I drew a submarine under the sea. Not 20,000 leagues under the sea because that's a really long way and like through the center of the earth out the other side. So Mr. Verne was a little wrong about that. But I thought it would be good to have a submarine because from a submarine's windows you could look up or down, right? They could be looking up at a ship they want to sink, or they could be looking down at something below them. So I think this is a really good example of elevation and depression. Elevation almost nobody ever messes up, right? It's just looking up at something. So when you start drawing the triangles in trigonometry, it's not hard to put the angle in the right spot because the triangle is supernatural. It's like something like that, right? So this is the angle of elevation. Pretty much we always get that one. But the key here is not this whole triangle, but this part of the triangle. When you have someone describing something as an elevation angle or a depression angle or anything like that, you need to think about their reference frame. You guys remember you watched that Einstein video and it talked all about reference frames? Well, this is a very simplistic version of that. Their reference frame depends on the horizontal where they are at. For this submarine, it's this horizontal. I don't know how deep under the sea it is, 20,000 leagues or 50 feet. But the horizontal is what it's all about in terms of reference frames with angles, okay? So you're either looking up, that's the easy one, or you're looking down from that horizontal. This is where the person's eyes would travel. They'd be looking, imagine them looking straight and then looking down. That is what is called a depression angle. So the mistake that's prone to be made is to be thinking about this triangle and call this angle the depression angle, which it is not.
That'd be an elevation.
Yeah, that would kind of be like something like that. You said that would be the...
That would be an elevation if you're looking down.
Yeah, if you were looking like straight down. Yeah, very good. Good point. Okay, so make sure you put your depression angle down from horizontal and that'd be good. And then you can use this triangle or that triangle. Which triangle you use is kind of up to you in that situation. Okay, I'm not going to do another example. That should be enough, I think. All right.